All right. My name's Pam. I am with Missouri Stream Team. I'm the Volunteer Education and Citizen Science Assistant. I'm really glad you're here and can see everything now. So we've got Ryan Morman here with us today. Let me see. We've got Ryan Morman here with us today. He's with KC Water, and he does education and outreach with them. And today's presentation, we are going to talk about the effects of stormwater runoff. Real quick, now that we've got a lot of people in here, if you want to, maybe you've already done it. If you want to put your name, kind of where you're from, are you with Stream Team, Master Naturalist, both, neither in the chat. Any questions that you have, you can put them in the chat and we will answer them at the end. I have started the recording. And so I'm going to bring it back to Ryan, and we can get this started. All right. Again, sorry for the technical difficulties, guys.
All right, good evening, everybody. Hopefully you can hear and see. My name is Ryan Morman. I am with KC Water's Education Outreach Team. And so this evening, I'm going to talk about the Missouri River, since it is National Rivers Month, the role the Missouri River plays at KC Water, and what KC Water is doing with the water. Because we are more than just one utility, because at KC Water, we are 3 different water utilities. We clean the drinking water every day from the Missouri River. We turn that water into drinking water. We also are taking the dirty water of Kansas City, and that is the wastewater that everyone is putting down the drains every day, and we clean that water. And then last, we also manage stormwater. And with my role at KC Water, it's primarily focusing on stormwater runoff. So during the school year, our program, we service a lot of school districts within Kansas City, Missouri. If you've ever looked at the city limits of Kansas City, Missouri, you can see it's a very big city in terms of our sprawl. We're in 3 different counties. And so my role visits schools within those counties that are in KCMO, emphasizing if it's on the ground, it's going to get into our water. Now, a little bit of background, though, about what's called the horizontal water cycle. So you're probably familiar with Earth's water cycle. And what we are doing every day is we start in the Missouri River. And we take that water, about 85% of that's going to become drinking water. About 15% of our drinking water comes from wells, but 85% is coming from the river. And then when that water is treated and cleaned, most households, businesses are using that water for cleaning. So just think over the course of the day, the many different ways in which people use water to clean. And so then that becomes wastewater. And because water is a natural resource that we can't create more of it, we take the wastewater, we clean the wastewater, and our goal is to make sure that the wastewater is cleaner than what the water is in the river, because that's where that wastewater is going to go. We will put it right back into our river. And you can see the connection between everything from stormwater, river water, drinking water. It's all interconnected. Right there is our treatment plant for drinking water in Kansas City. So you can see the Missouri River is in the upper left corner. And every day we are pumping on average about 100 million gallons. Now that it is summertime, that number's probably around 125 million. We have the capacity to actually treat about 240 million. So even in summertime, when we up how many treatment gallons every day, we are still not even at half capacity. So that's anticipating if Kansas City grows that we can meet that need for more drinking water. But we only have one drinking water plant, which services about 1 million people. And our drinking water plant is also equipped with a nationally accredited water laboratory. And so our chemists at our drinking water plant in the lab, they're doing tests every day on drinking water, river water, stormwater, wastewater. And they are taking tests at every sample, every stage of the drinking water process, making sure that we are meeting the standards of both the EPA as well as the Missouri Department of Natural Resources. But we have 6 wastewater plants. And right there, that's our biggest wastewater plant. That's the Blue River wastewater plant. And just that volume of wastewater that humans make, that's why we have 6 of them spread throughout Kansas City. And you can see right there, there is the Blue River. And the Blue River will receive the water from the Blue River wastewater plant. And the Blue River will then empty into the Missouri not too far from this location. Now, we are also working with distribution, collection, but I want to talk about stormwater because that's really what my field is in. So my role is a part of what's called smart sewer. And back in 2010, the EPA put a mandate on Kansas City known as the MS4 consent decree. And in that mandate, Kansas City had to address stormwater runoff. And it was not just in terms of addressing the infrastructure, but also educating the community about stormwater runoff. And if you're in the St. Louis area, you might be familiar with what they're doing over there. I believe they're working on something called Project Clear. Now, St. Louis is a much older city, so they have a different set of problems compared to Kansas City. But a lot of major metropolitan areas around 2010 were under this consent decree by the EPA to do something about overflows of stormwater, especially in older areas where sewers and stormwater drains were combined. And so you can see right there, it started in 2010. And right there, that is the city limits of Kansas City. And so you can see it's a little bit tricky because you can tell there are other cities that are literally encircled by Kansas City. And so downtown Kansas City is the blue right there. The older part of Kansas City is that blue. And because the older part of Kansas City was built first, everything was combined storm and sewer. The green, what you see there, that is newer development in Kansas City. And that is all separate storm and sewer. So I would guess that St. Louis, if you're in the St. Louis area, being an older city than Kansas City, it probably has a lot more combined sewer storm systems compared to us. But we still had a runoff problem. We had an overflow problem that we were trying to fix. And so that looked like over the years, we started to look at areas where could we better absorb stormwater? How could we cut down on flooding? Because flooding is not just a problem for homes and roads, it's also going to be a problem for pollution. Because if it's on the ground, it's going to get into our water. And so you can see our long-term goals right there of smart sewer. We are trying to capture as much rainwater as possible. Because think about before pavement and concrete was everywhere, where did most rainfall go? Well, it would go back into the ground as groundwater. When humans paved and created concrete all over the world, that's kind of stopped the groundwater, or at least the rain becoming groundwater. It now became water on the road, in our storm sewers, and then putting pollution into our nearest creeks and rivers. Now, I'd like to talk about water education, what I do. So part of this consent decree that we do at KC Water is we have to go visit schools and educate students about how if it's on the ground, it's in the water. And you can see right there, our program covers all ages from pre-K all the way up to high school. We make sure that every lesson that we do with students is connected to what they're learning in their classroom, but also connected to what we're focusing on with storm sewer. And so one of the things we like to emphasize is the importance of watersheds. Because no matter where you are in the world, you are downstream from something. And so in Kansas City, over here, we have our local watersheds. And what this map you see right there, these are all of the creeks and small rivers in the Kansas City, Missouri region. Now, no matter how big or small, all of these creeks and small rivers are going to flow into the Missouri. And so right now where I am at, I'm in the Blue River watershed where our office building is. And you can see the Blue River will go to the Missouri. But if I go and visit schools up in the Northland, I might be in Shoal Creek watershed. And even though Shoal Creek is much smaller than Blue River, it is sending the water to the Missouri. But then we have to zoom out and think about where do most of the rivers go in the United States? And most of them are going to go to the Mississippi. And so the Mississippi River is actually the third largest watershed in the world, behind the Congo and Amazon rivers. And on the map on the right, bottom right, you are seeing all of the different rivers on both sides of the Mississippi that are feeding into it. And so where we are in Kansas City, we're almost at the end of the Missouri River's journey. But we are downstream from Omaha. So if Omaha gets heavy flooding, we're going to get that. But then St. Louis, since St. Louis is downstream from Kansas City, they're going to get all of our problems that may come up during a flood. But then that water is going to keep moving. And when it gets to the Mississippi River, it's going to get into the ocean. And it only takes about 2.5 to 3.5 weeks approximately. So that's about 17 to 24 days. So if we were to get rain this evening in Kansas City, that rain could be in the ocean as earliest as June 21st. But it's not just the rain we have to focus on, it's the stuff that's on the ground. And we can see here the problem is that a lot of our world is paved. And so we can already see in this image that we're getting puddles and we're getting runoff. And if it's on the ground, it's going to then go into a storm drain. So it's a very common misconception people may have when they see these outside to automatically assume they are the sewer. But most of the storm drains in Kansas City are not even connected to the sewer. About 75% of our storm drains are totally unconnected to sewers. And storm drains are sending that rainwater to the nearest creek or river. So it might go to a creek first, but it's all going to get to the Missouri River eventually, since all of our creeks in Kansas City will go to the Missouri. And we can kind of see right there a visual of the difference between separate and combined. And older towns, I believe I was looking up, Philadelphia has about 90%, or at one point 90% of their pipes were combined, since it's an older town. So older towns in the United States, they're going to probably have mostly combined storm sewer. Newer developments are going to have separate. And you can see that in the separate ones, the rain is just getting sent to the nearest body of water, while the wastewater will go directly to wastewater to get cleaned by us. But this is the problem: the trash and the pollution. So we think of the trash because we see it. When you're driving around, you notice the trash on the roads, in grass. We can see that, but that's not the only thing that's going to get into our water. And time of year can also depend what kind of pollution is going to get into our rivers. So now that it's getting into summer, chemical pollution like fertilizers, pesticides, weed killers, if those things are not applied properly, they can easily wash off yards, down driveways, and into a storm drain that will go right into a creek or a river. But year-round, we have to always deal with oil. We know oil and water will not mix together, so the rain is just going to push that oil down a storm drain to the nearest creek or river. But even things like leaves, because we can see some leaves covering this storm drain right here, not only is it clogging the drain, which will then flood that water back into the road, but when we get a lot of extra leaves and water, they're going to decay. And when they decay and decompose, they're going to use the oxygen from that water. And so when that decomposition of leaves and other organic material, when all of that's decomposing in our creeks and rivers, that is leaving less oxygen available for the animals, the fish, the macroinvertebrates that might be in that water. And even with fertilizer, fertilizer can cause algae blooms. And same thing, algae, when it takes over a creek or a pond or a lake, that's going to steal the oxygen out, and then fish can start to die up. Now, here is what we are always seeing, the trash, at least in Kansas City. Driving around Kansas City with this job, unfortunately, I see our trash and dumping problem throughout Kansas City. Now, not everything that we see in this picture can fit down a storm drain, but a lot of it can. The smaller stuff is going to move. And then here, this is Brush Creek down in the plaza. And Brush Creek, this is what it will look like the day after a heavy rain. And we look at this trash, most of it we can see is made out of plastic. And so with the plastics, as you probably are aware of, when they get into our water, they're going to stay in that water for a very long time. Around 500 years or so for the plastics to stay in the water. And that's not even addressing the microplastic problem. Now, as dirty as this creek is, we have to remember, where is it moving? Well, and because it's in Kansas City, all of our creeks are going to go to the Missouri River. So this water is going to carry the trash and the pollution from the Brush Creek into the Missouri River. But something people don't see is the other side of what the trash is doing into our systems. So what you are seeing here is all of the trash in one pump station. And I believe we have 66 pump stations in Kansas City. This is all of the trash collected in less than a day. So it's not all going into creeks and rivers. A lot of it's getting stuck in our equipment. And you can imagine what has to be done if this gets stuck in augers inside our pump stations. We have to stop. We have to go inside, fix them, find the right parts. And every day, our wastewater plants are removing so much debris, leaves, trash. It's on and on. And so we have to think about parking spaces. How much rainwater can parking spaces hold? Because a lot of parking spaces are impervious, where the water is just going to pile up, and then go to the nearest storm drain. And then it's going to go into the nearest creek, the nearest river, and then in a few weeks, that water, that pollution is now in our ocean. And so not too far from our administration building in Kansas City, we're not that far from Arrowhead and Kauffman stadiums. Now, on average, a parking space that you see here is about 18 square yards. And an inch of rain, if you were to put an inch of rain here, it would hold 108 gallons per every parking space. And at Arrowhead and Kauffman, they have 22,000 parking spaces. And so if we were to get an inch of rain in Kansas City, the parking lot at the stadiums would create about 2.376 million gallons of water that will stay in the parking lot and then go to the nearest storm drain. Now, there are bigger parking lots in Kansas City, like the airport, for instance. But the difference between the airport and the stadiums, people are not tailgating at the airport. When people go to the stadiums for either a sports event, a concert, and they tailgate, they're making more trash. And it'd be great if everyone was cleaning up after themselves, but we realize that that's not the case. And so any of those issues are going to then wash away from the stadium. About 2.3 million gallons of rainwater will wash from the stadium to a storm drain, and it will carry everything that's on the ground into our water. Now, a little bit more about what we are doing with Smart Sewer. We are trying to make this light blue number smaller and smaller over time. Because the older part of Kansas City, everything was built combined. And why did people do that? Why did they combine storm and sewers when they were making towns a long time ago, well, there was less people. And if there's less people, there's less wastewater. And so for a long time, it wasn't a big issue until Kansas City grew. And when Kansas City grew, more people make more wastewater every day. And so when you have more people with heavy rain, you can follow the path on the bottom here. You can see that the overflow is going to go into creeks and rivers, and that overflow is containing sewage, wastewater. And that creek I showed you earlier, Brush Creek, with all of the trash in Kansas City, it has gotten the nickname of Flush Creek because of this old system that can sometimes put wastewater on heavy rain into the creek. Now, we are aware of this problem at KC Water, but it takes time for us to go in to isolate areas in which we can tear apart the ground, separate, put in new pipes. But the good thing is most of Kansas City is separate. About 75% of our pipes are separate storm sewer. So the one you see on the top. But even though they're separate, you still have to remember there's still any pollution on the ground can still get into our creeks in a separate storm and sewer system. And so I'm a part of our education outreach team. That consent decree required an education component where we go out and we educate not just students, but even neighborhoods, colleges, any organizations, any stakeholders in the community. We educate them about stormwater runoff, the best management practices, the goals of what KC Water is doing. And that comes into the gray infrastructure. But a big component of what we are doing is the green infrastructure. And earlier I talked about how when we had rainfall before concrete was everywhere, that rainfall would be returned to earth as groundwater. And so in these areas of Kansas City that are still part of the combined storm sewer, we're building green infrastructure locations. Usually in areas that are prone for flooding, areas that were usually paved, we go in there and we redevelop that land and we put in a lot of native plants. And so when it rains in this picture, you can see it's on a hill. A lot of that rainwater is now going to be diverted into the green infrastructure. And the native plants do a really good job of holding on to rainwater. They can absorb more of it. And this is another way that we can cut down on both pollution and flooding. Because if we have less water on the road, that's going to be less of a burden on our system, but it's also going to carry less pollution and trash into our river. But we do like to encourage people to think about their own house and what they can do every day. Because a lot of little things can add up to a really big, cleaner environment if we kind of focus on what we can do. So making sure that we're putting our fertilizer down properly. If it's a really windy day, probably shouldn't put it down. We want that fertilizer to be in the ground, not down our driveway into a storm drain. In the wintertime, the same can be said for salt. Because going to creeks in the winter and doing water testing, our creeks in Kansas City get very salty because we put a lot of salt down for snow and ice. And you probably have seen, because I see it a lot, where after all of the snow and ice is melted, we still notice big chunks of that salt in parking lots and sidewalks. And that's just waiting for the next rainfall. And when salt gets in our creeks and rivers, it's going to make it more conductive actually for an electrical current. It's a dissolved metal. And that's another problem that we can have when we get salt into our creeks and rivers. So just making sure we're putting enough, just the right amount of salt down in our driveways, making sure we are applying fertilizer properly so it's getting absorbed into the ground. Some of these take a little bit more effort, but if you're able to have a rain barrel, if we're able to capture rainwater from our downspouts, just think about if every home in Kansas City or in every home anywhere, if they had one rain barrel capturing rainwater from their gutters, that's going to cut down on runoff. And then you can repurpose that water for your garden. We want to make sure that if people have hazardous waste, that they are not just dumping that down either their toilets or dumping it down a storm drain outside. And so we have a hazardous waste drop-off site that KC Water operates. And so people can go in and they can dump off anything they want, whether it's paints, oils, any kind of chemicals, liquids that might be in their garage or basement. We can recycle those. And that's another project of KC Water, taking care of those hazardous wastes so it's not getting into our river. And same with even prescriptions, making sure that we're not just putting our prescriptions down the drain, because that can then get into our local waterways. Making sure our car washes are not sending the dirty water right into a creek or a river. I actually saw this up in Riverside, Missouri, which is a small town north of Kansas City. There was a manual car wash, and we just so happened to be at Line Creek in Riverside that day, and it started to rain a little bit. And we saw from that manual car wash the amount of soapy water that was getting deposited into Line Creek. And like all of the other creeks, Line Creek goes to the Missouri River. Most car washes, especially big commercial ones, they have the drains. They're going to send that to wastewater, so it's not a problem. One of the service projects that we are doing with schools is marking storm drains. And maybe at some point you have seen a little marker on a storm drain saying no dumping leads to waterways. Because it's a very common misconception for people to see that drain and think, oh, it's the sewer. I can put anything I want down there. But that's not the case. And really just cleaning up what we can. We are able, and we have sometimes worked with stream teams at KC Water to do litter pickups and to clean up nearby creeks, making sure that less of that's going to get into our water. Of course, having more plants, more native plants, more trees absorbs more rainwater. But these are just some of the possible solutions that you can do at your own house. And we also like to encourage trying to use less plastic. Like I said, plastic is going to stick around for hundreds of years. So if we use more reusable materials, more reusable bags, reusable straws, reusable bottles, and that's a great thing I see when I get to visit schools. So many kids now have their own reusable water bottle. And it's great to see that they're not wasting plastic, that every day they're able to use the same bottle and cut down on plastic trash that could get into our waterways. And we have that silly picture there of the dog for a reason. Because I said if it's on the ground, it's in the water, and that is anything, including dog poop. And so when we get a lot of animal waste into our creeks and rivers, that's going to create phosphate and nitrate blooms. And if you've ever walked around a creek before and you see a lot of foam bubbles in a creek, that's not always soap. That could be phosphate pollution, which is one of the byproducts from animal waste. So we don't obviously control the animals, the wildlife out there in nature, but our own pets. If we're able to pick up and dispose of the pet waste so it's not getting dissolved and getting into our water. And that's a little overview of what we are doing here at KC Water, how everything is connected. And if there's any questions, feel free to put them in the chat.
All right. Let's see.
Actually, no. We're lucky that there's no limitation on how much stormwater you can collect. So if you're talking about like a rain barrel, there's no limitation on that at your own house. I know out like in Arizona, because they have so little rainfall out there, that it's actually illegal, I believe, that you can't even have a rain barrel because they need that rain to recharge the groundwater. At least in Kansas City, we're very fortunate that there's a lot of groundwater already, and we're not even tapping into that. But it's really going to depend on where you live, because in Western Kansas, it's a different story because they rely on the aquifer out there, and that can start to dry up. But at least in Kansas City, there's no limit. And I think for the rest of Missouri, I don't think there is any limit on how much stormwater you can collect at your house.
All right, it looks like we've got another question here. I'm just going to read it out loud for the recording. Um, Rebecca says, I'm curious about how cities handle who owns stream property. When cities direct stormwater into these creeks, who is responsible for erosion damage?
That is a good question, and I am not actually entirely certain on who is in charge of the erosion damage. It's might be like a municipality by municipality case. Um, but yeah, that's another thing to consider though, because erosion definitely puts in a lot of dirt, other metals and minerals into our water, which can pollute the river as well.
Yeah, and I'm not sure about that either, but I can ask and see if we can get an answer for that one.
So when we are testing streams, how often are streams tested? With what I do, that's really a case by case basis. We usually are testing streams with middle and high school students, and that's more of we test to kind of figure out the runoff in that area. Now, I know at our lab, they are testing our waterways every day in Kansas City. So the chemists, they're taking samples from creeks, they're taking stormwater samples, and constantly seeing what's getting in there. And that's why we're able to kind of pinpoint in the northland of Kansas City, our biggest problem is chemical pollution because it's a separate storm sewer. So it's not getting as much trash, but we can tell at our lab that a lot of the chemicals, fertilizers, pesticides, that is our big issue. And so I don't know in terms of how often they're testing our streams, like how many times per day, but I know that our lab chemists are taking samples of the creeks throughout Kansas City and seeing what runoff has gotten into them. Are there grants available for people to put in rain gardens? I don't know if we currently, I don't think KC Water currently has any grants at the moment. I believe at one point we did. That might have been before I was hired, though. Um, so in terms of grants for people making their home more stormwater efficient, you'd have to check on where you live. There might be, but at the moment, we are not offering any grants for individuals to do that. And it looks like we had another question.
Yeah, I think we had two more. I think first came in from Joshua. It says, is Casey Water doing any work towards making a parking lot topping that would allow a well draining parking lot?
Are you talking about like a roof that can absorb rainwater, stormwater, and having those around town? Because I do know that our downtown police building in Kansas City, that is a green infrastructure site because what they did on top of that building is they put in a lot of green on top of that building to absorb that rainwater. In terms of parking lots, I'm not sure if we are putting any green spaces on top of parking lots. But we are going into neighborhoods that traditionally have a lot of flooding and basically creating man-made creeks or ponds essentially, which is going to capture the rainwater from nearby subdivisions, and then it fills it up as a basically a pond filled with rainwater. So even if it's delivering a bunch of pollution, it's going to a site that is just going to slowly over time absorb or evaporate back into the sky. What other questions? I know we had a few more pop up.
All right, here's the next question from Rebecca, or just a minute, I think. Let's see. She says, I think this is a comment, so we can go to the next question, but she says real quick, it's so interesting that public health information can be gained by testing for pathogens in wastewater. So
Yeah, and
that's
that.
interesting.
Mhm. Yep.
But let's go to the next question here real quick. Um, what is something about your work that you wish you got to talk about or were asked more often?
Actually, an event like this webinar is something I wish we could do more often. A lot of what I do is talking with students, and that's very important. but students are not the ones paying water bills. They're not the ones managing their homes, their yards. So getting to talk to adults more often is something I wish we could do with this program. Ways that people could try to stormwater manage their house a little bit better. Um, Seeing that connection, I don't think a lot of people really can see that connection. I know sometimes when I go out to events in the community and when I talk to adults, they have no idea where their stormwater bill, where that money is going. They have no idea about green infrastructure. I think it's something kind of out of sight, out of mind for a lot of people. They don't really think about where does the rain go or how does it carry their chemical pollution or the trash into a nearest waterway. So that's something that we hope to grow, is to make sure more of the policy stakeholders in Kansas City are aware of this as well, not just the students.
All right, it looks like we had a follow-up to the one Josh asked earlier in the chat about parking lot toppings. He added, it was something I think they were working on in Japan. It was like a pumice that allowed the water to flow. So I think he's talking about like the actual substrate of a parking lot.
Well, we do have green infrastructure parking lots. Actually, here at our office building, that was the very first green infrastructure project Casey Water put in, where we are able to create different types of permeable surfaces. And some of them let the rainwater go underneath into the soil. Some of them have basins underneath, so we can capture the rainwater in a big basin underground, and then we slowly release that water over time. So there's different ways that you can capture it. It's not all just trying to get it absorbed into the ground. In certain areas, we have these detention basins that capture the rain and then slowly puts it back into our waterways. And if you look at any green infrastructure site, everything there is by design. So the rocks that you see there are by design, the way the curb is designed. Look for little openings. Everything there is designed to either slow down rainwater. So having rocks, even small gravel creates friction where it's not rushing into the nearest storm drain, it's slowing it down. And one of the things that we do at our parking lot here at KC Water is twice a year, we have trucks come through and vacuum out all the gravel in our permeable pavers because gravel can get coated with oil. So we don't want that gravel to get hydrophobic over time. So that's why we go through there twice a year. We take out the gravel, put new gravel down because it can capture that oil as well as slowing down that rain flow so it's not overwhelming our storm sewer system.
All right, and it looks like we had one more question. How do you inform the public if drinking water is not safe to drink?
Well, that would be probably more with our laboratory. And I know last year, actually, back around July, we had to do an adjustment of our drinking water for about a week or so because there was heavy flooding up in Omaha. And so what that did was we had to go through and put in, we use activated carbon if there's a lot more pollutants in the water, because activated carbon can capture more of the chemical pollution that might get into that water. Our chemists are working with the DNR, making sure that everything is meeting the standards of both Missouri and the EPA. So every now and then we may have to kind of tweak the amount of chemicals that we put into the treatment process, depending on what we receive from up north. And so if you're near the St. Louis area, same goes there. If Kansas City gets heavy rain, that may adjust the treatment process of what happens down in St. Louis just because you are downstream from Kansas City. But I think it's every 4 hours at all of our different basins at our drinking water plant, they are capturing samples, taking it to the lab, and ensuring that it's meeting the standard at each part of the treatment process. Because it takes about 18 hours in total for us to turn river water into drinking water. And so we want to make sure that every step along the way, there's nothing out of the ordinary. And if we see something out of the ordinary in, let's say, our primary basin, then we can go and do the change needed. But if then it goes back to normal, we can like remove that activated carbon. So it really is kind of a case by case basis.
All right, I think this is going to be the last question, then we can wrap up. Are low flush toilets a good option?
Yeah, in terms of water bills, in terms of how much you're putting down, where you are located might determine too. So if you're in an area where it's combined storm sewer, if we're putting less water down in a combined storm sewer, that's great. If you're in an area where it's separate storm sewer, probably not a big of an issue since all of that's separate from the storm drains, but still it's going to be less water usage for your home.
All right, there's still another question came in. There's still a little bit of time. So, how bad has the Asian carp invasion affected the Missouri River?
The Asian carp,
Yes.
I'm not sure. I don't know too much about that. So I'm not sure in terms of how that's affecting our drinking water, but I can look into that to figure out if that's an issue that we are facing at our treatment plant.
All right. Well, that was all the questions. I want to thank Ryan so much for being here. It was really great to hear from him. If there's any other questions, you can go ahead and put them in the chat. We can try to get them answered. We're going to send an email out afterwards with a link to the recording. If there's any unanswered questions, we're going to try to get them answered. And thank you all for being here. One last thing that I need to plug for you guys. Like we mentioned, this is for National Rivers Month. So if you want to log this as your activity report, a National River Month activity report, you can put it in so you can receive this awesome sticker here. I want to thank everybody for being here today. But we're going to go ahead and wrap it up for now.